Today we're going to talk about inside and outside design conditions, two of the most important factors we use when sizing HVAC equipment. Really, this is where this worksheet begins. In the whole house heat loss and gain worksheet, I have it highlighted at the top section in green under design conditions. So before we can select any equipment or do any load calculations, we need to know the target indoor temperature and the expected outdoor temperature. So these are called design conditions. In the wintertime, you have an indoor design temperature target you want to try to shoot for and maintain. In the summertime as well, you have an indoor design temperature you want to shoot for or try to attain. That is called the inside design temperature. And the outside design temperature is the outside of the house, right? So outside the home, we have air or weather that affects the home absorbing heat or losing heat, depending on the weather or the season. So for the inside design target temperature, ASHRAE and all these other companies and agencies and groups have done studies years and years ago and found that in the wintertime, the temperature that most people felt comfortable in the wintertime is 70 degrees. So this number typically doesn't change. So you can put 70 degrees right here. In the summertime, the studies show that most of the time, people feel comfortable in around 75 degrees inside the building. So the inside design temperature typically is going to be 75 degrees. So you could put 75 degrees right here. So if you look at this, these are going to be your winter inside design temperatures of 70 degrees and your summer inside design temperatures of 75. So that means that our equipment is able to cool down to 75 when we have a very high heat load. And that our heating equipment can heat up the house to 70 degrees when it's really cold outside. So those are our target temperatures for inside the home. Now, what about outside the home? The outside design conditions, because that's the second part to design conditions. Then where we were talking about the sun, clouds, wind, rain, and the outside design conditions are based on the weather and the building location, right? So we don't pick the absolute hottest or coldest day ever recorded. That would make the system oversized and inefficient. Instead, engineers use climate data collected by ASHRAE and weather stations, and they find out what is the average temperature that they've found to be hot or the average temperature that they found to be cold. And so these outside design conditions give us a realistic challenge for systems without going overboard. In other words, most of the time when it goes over that high extreme temperature, it's only for a few hours. So we don't want to design the unit to crush that high temperature all the time, because we still want to rely on the home, insulation of the home, the window quality of the home. Nowadays, there's more energy efficient design parameters that we're looking at or involved in the home. So here's the big picture. Outside design conditions set the load on the house, that where the heat is trying to get into the home in the summer. It's where the heat from inside the home is leaving the house in the winter. Going back to heat will always travel from a warmer place to a colder place. That's going to be the temperature difference taking place between the inside of the home and the outside of the home. The inside design conditions set the target. In other words, we are trying to meet that temperature inside the home. So to wrap this up, always remember, inside design conditions is the goal of the inside environment. The outside design conditions is the expected challenge. That's what the house has to work against during those seasons: the wintertime, the cold, the summertime, the heat. So together they form the foundation of every load calculation and system design.